All right, this is for the people who are gone. Today we are doing notes for section 2.6, which is this guy. We actually skipped section 2.5. So if you're wondering where that's at, 2.5 we skip over. We go straight to section 2.6, but yesterday we began doing this and we filled out these first two columns, okay? What I'm going to do is I've erased those two columns so I don't have to keep going back and forth. We're going to fill out this third column right here. Which is the x squared column, okay? So, here's what I want you to do. Focus your attention on this x squared column. What I'm going to do is I erased this second column, and I'm going to pretend that this is the y equals x squared column just so that I don't make you dizzy going back and forth. Can I do that?
Oh, yeah.
So you're going to write all your information in this third column. I'm going to write it in this column just so that I don't make you dizzy going back and forth. Agreed? Yeah. Happy with that? Okay, let's talk about y equals x squared. What does that thing look like if you are to graph it?
Parabola.
It looks like a parabola. It looks like this, right? Okay? And it is a quadratic function. So if you want to put quadratic, above that column, write the words quadratic and put the graph of what he looks like in that spot. Okay? Quadratic, there he is, all right? All right, let's just do this column now, and then we'll go to the notes, and it'll make notes go a lot faster then also, okay? So let's say I'm starting with y equals x squared. That's my parent function, and I want to translate it 6 units up.
X squared plus 6.
Y equals x squared plus 6, yeah? We know that maybe? Okay? All right, vertical translation 5 units down. Y equals?
X squared minus 5.
X squared minus 5, yeah? Happy with that? Those ones are easy, right? Okay, now going 9 units to the right. Okay, you have a little note over here that says use the opposite sign. So 9 units right is going to involve using a negative 9 instead of a positive 9. But where does that negative 9 go?
Negative x. Parentheses with the x.
In parentheses with the x.
Yeah.
So I have x minus 9 and then what?
Square.
Square on the outside, right? Okay, that's the difference. So you see that this is very different from just the x squared minus 5. The x minus 9 goes inside the square, right? Okay, and then 4 units left, that's going to involve a plus 4 because you're using the opposite sign. Left, I think, minus, but it's the opposite, so it's plus 4. And so it's going to look like y equals x plus 4 squared. Okay, make sense? Yeah. All right, vertical stretch by a factor of 5. Remember that stretches and compressions involve multiplying, so we're going to be multiplying by that number. What will a vertical stretch by a factor of 5 look like? 5x squared, just like that. Ooh, you can't see my square very well. Squared. Let me get my pen a little smaller here. There we go. Okay. Vertical compression by a factor of 1/3. Y equals 1/3 x squared. Okay. All right. Now, these next two are going to be a little bit different. A horizontal stretch by a factor of 2. We said over here off to the side, use the reciprocal. So instead of using 2, we're going to use the number 1/2 instead, right? Okay. So it's 1/2 x squared, except it's in parentheses.
Can you scroll up a little bit, please?
1/2 x squared like that, right? 1/2 x squared. Okay, now that actually means, if you're taking 1/2 x squared, that really means like 1/2 x times itself twice, right? 1/2 x times 1/2 x. What is 1/2 times 1/2? 1/4. So really, when we're simplifying this, this actually comes out to be 1/4 x squared. Does that make sense? Yeah? If we simplify it. So there is a little bit of a difference between vertical, which is these two, and horizontal. You have to square the number also, right?
And then
Okay.
it ends up without the parentheses?
Yes.
So then does
Yes.
that
So
mean,
you can take it by squaring it, you can let the parentheses out. Yes.
so does that mean y equals 1/3 x? Is it y equals 1/3 6? Or y equals 1/6?
No, because the only thing that you're squaring in this one is the x. Versus in this one, you're squaring the 1/2 and the x. That's the difference between vertical and horizontal. Does that make sense? Ish.
Okay.
Let's do this next one. So horizontal compression by a factor of 1/4, you're going to use actually 4 as a number, not negative. Don't get negatives in there. You're going to use actually 4, but it's 4 in parentheses. So it's 4x squared. What's 4x squared actually?
8x squared?
What's 4 squared? 16x squared. So if I get rid of the parentheses, this thing is really saying 4x times 4x, right? 4x times itself twice. 4x times 4x is 16x squared, right? So it's squaring both the number and the parenthesis, or and the x when it's in parentheses. Okay, good. All right, this next one involves a negative. So if you look to your linear column, this is y equals negative x where the negative is outside of parentheses. This one is y equals negative x when the x is inside parentheses, right? That's what your first column says. Now, if we apply that to the square, this will just be y equals negative x squared, right? Okay, now, this one's kind of fancy. The negative is inside of parentheses for the second one, right? So it looks kind of like this, negative x squared, right? Like that. But if we take negative x and square it, it's like negative x times negative x, right? That's what that means. So it's just y equals x squared. Now, how the heck does that work out? Because that's what we started with. Why is it back to what we started with? We started with y equals x squared. How is that the same as what it was before?
Because if you reflect it,
Yeah, y equals x squared is a parabola that looks like this. And if I reflect it across the y-axis, I'm just flipping him this way, right? And he's going to be the same, right? Because he has that axis of symmetry, that line of symmetry. And if you flip him, he's going to be exactly the same. And that's why this guy is x squared for, it stays y equals x squared for a reflection across the y-axis. Does that make sense? Okay, was that a little bit better, that column, than it was yesterday? Like sinking in a little bit more? Okay, the more you do this, the better it will become. Let's go down to the next page. So 2-6, this is your note sheet. Flip to your note sheet. This is what this looks like. I have a box here that has all of the things. So vertical shift, horizontal shift, vertical stretch compression, horizontal stretch compression, and a reflection. Okay, all of the things. And I'm going to skip over those, and I'm not going to go into too much detail because we've already done that on your chart, right? But the one thing that I will say, let's talk about stretches versus compressions. Stretch, compress. Okay, they call those dilations. Have you heard the word dilate before?
Yes. They usually say when you're talking
Dilations?
about your eyes.
It usually you're talking about your eyes dilating when it's light and dark, in the room.
is it?
Okay, dilations. Okay, those are dilations. Now, how do you know whether it's a stretch versus a compression?
Stretch up and compress.
Stretch is making it taller or wider, right? Compress is making it skinnier or shorter, right? Okay, but numerically, what will the numbers look like if it's a stretch? What will the numbers look like if it's a compression? Bigger numbers. Like if I just think about your height. If I'm stretching your height, I'm like making you twice as tall, or 3 times as tall, or 4 times as tall. So it has to be a number that is greater than 1. That's the key, right? Okay, if it is a number that is less than 1, like you're half the size of what you were before, that's compressing, right? So a number that's less than 1. All right, now, what if the number is exactly 1?
The same.
You're taking your height times 1, so it's not changing your height, right? So it has to be a number greater than 1 or less than 1 to be a stretch or compress, and otherwise we're just leaving it the same. Does that make sense? Bigger than 1, like doubling your height or tripling your height. That's taller, okay? Compressing half your height, a fourth of your height, etc. Those are compressions, yeah? Okay? All right, let's move on. Example 1. This is how I want you to tackle each one of these problems, and the ones on your homework assignment are similar to this. It's a very short homework assignment. That's not short, but it takes like not very much time at all. Okay? Describe the transformation. Y equals the absolute value of x plus 2. The first thing that I want you to do on each one of these problems is identify what the parent function is. Okay? So this is the function they give me, and if I strip away all of the numbers, what's left over? Y equals the absolute value of x. That's the parent function, right? Okay, on the front side of your transformation sheet, we have what the y equals absolute value of x looks like. What's it look like? Y equals the absolute value of x.
It looks like a V.
It looks like a V, right? We know that, okay? And it's a perfect V. So be kind of picky about the way you do your V. Don't just willy-nilly make a V, right? Okay? It is, your V starts at 0, 0, and it goes up 1 over 1, up 1 over 1, up 1 over 1, or up 1 over 1 the other direction, right? That's what your V looks like. So it's a perfect 45-degree angle in both directions. That's what y equals the absolute value looks like. That's just the parent function. Just the parent function. Just wait. Just the parent function, okay? Now we have to decide, I'm going to do this in a different color, what is the 2 doing?
It's sliding it over.
So what is the transformation?
It's sliding over to the right 2, please.
It's going up 2 units, right?
Oh, okay.
Up 2 units. Good?
Hang on. So what is this? Transformation?
Y equals X squared.
Okay. So we're going to start at, instead of starting at 0, 0, we're going to go up 2. And we still go up 1 over 1, up 1 over 1, up 1 over 1, or this way, up 1 over 1. Whoop. And that's what your up 2 units looks like. So when it says describe the translation or describe the transformation, it's up 2. And then that's what, the orange is what he actually looks like when we're done, right? Graph the function. Good?
Do you
I have
want
a
us to
question.
do the parent function?
Now, on the homework assignment, you don't have to graph the parent function. I think it's helpful sometimes, but you don't have to. Make sense? Okay, you don't have to. You have to tell me what the transformation is. So up to, that's what you need to do. What?
Why
So
do they
what's
go
the-
up and not over?
Why do you go up and not to like to the right or to the left?
Yeah.
Okay, right or left would be absolute value of like x plus 2 inside of the absolute values. That's like inside parentheses. This would actually be which way, left or right?
That would be to the left.
That would be to the left because it's the opposite direction of what you think, right? So that's
in
left
order
too.
For it to move left and right, it has to be inside.
It has to be inside of the function, right? Inside of the function. Okay? Let's go down to this guy. Y equals the absolute value, or excuse me, x squared minus 7.
So for the answer, what would we put? Like, would it just be up to? Or
Yes, up to and graph the
do we
graph
have
the yellow.
to like write out the parent function?
No.
Okay.
I mean, I think it's helpful, but you don't have to. Okay? The parent function in this case, y equals x squared. You betcha. Okay? And then from there, okay, let's graph y equals x squared. Now, y equals x squared is a parabola. It starts at 0, 0, but let's be more specific about this, okay? X squared is what we're doing. If we go over to 1, 1 squared is 1, so we're 1, 1, right? 2 squared would be at 4, right? So we would get over 2, up 4. 3 squared would be at 9, so we'll go over 3, up 9, okay? And we do the same thing to the other side. So negative 1, 1, negative 2, 4, negative 3, 9, etc.
And then we draw.
Okay? All right, now, what's the transformation, though?
Down 7.
Down 7. Okay? So instead, we're going to start at negative 7, okay? And if I would go 1 over, I would go 1 up. If I would go 2 over, I would go 4 up. If I go 3 over, I would go 9 up. What's 9 up from 7? Negative 7. 2. Positive 2 is where I will end up. Does that make sense? Okay, and then I do the same thing on the other side. Okay, so we can be kind of have good points in there, right? That's what he will look like. Something of that nature, right? Okay, and that's where he will live. Yeah? Okay, let's go down to reflections. So the parent function in this case, y equals negative x squared. His parent is just x squared, right? Just x squared. Okay, we still have the same one as what we were doing before, so 0, 0.
This is a
Why isn't it
reflection.
negative x squared?
Okay, so the parent is if we strip everything else away. Now we're going to talk about what the negative is doing to the parent,
It's a
right?
reflection
Yes, it is a reflection.
across the x-axis.
Across the x-axis, yes, you betcha. Okay, so this is what the parent looks like, and now we have to decide what the negative is doing. Caitlin says that the negative, the transformation that's happening, is that it is reflect over the x, okay, which is going to make him do what?
Just flip down.
Flip down. So over 1, down 1, over 2, down 4, over 3, down 9, and the same on the other side.
Does it have to be exact?
What do you mean?
Like,
Put those dots in there and then it will be fine.
but do you have to do that?
Yes,
Why?
because otherwise your parabola looks all willy-nilly.
What if
Did I get
What?
a picture of her?
What?
Picture of her.
Can you wait like 5 minutes?
I guess I.
Okay.
Why do you
All right,
have
so
to
there's
do
that. Okay, moving on. Happy with that ish?
For number for like, the example 1 for number B, what was the translation? Was it just the translation
Up to.
down?
For number 1?
No, for
For B, down
yeah, for
7.
B.
Down 7.
So for y, It would always have to be in parentheses for a reflection of y.
Yes. Yes.
That's fine.
Yes.
Yeah.
Reflection over y has to be in parentheses. Or like this one, like let's say y equals the absolute value of negative x. That's kind of like in parentheses, right? The absolute values just take place of the parentheses, right? So that's an example of that, okay? All right, let's go to the back side. Now we're doing dilations. What does a dilation mean again?
That's making it bigger.
Stretch or compress. So we're doing stretches or compressions.
Do you have a problem with me?
Okay, stretch or compress. All right, I'm going to start with the parent.
Stretch or compress.
If you strip the numbers away, the parent is what?
Sorry, my handwriting sucks.
Y equals x. That's the parent. If I strip the 4 away, y equals x. What is y equals x? What kind of function is that?
It's a linear.
It's linear. We've graphed linear functions before, but we have to start at something. Where do we start at here?
0.
Plus 0. Yeah, so we start at 0 and we go?
Up 4 over 1.
No, well, for the original, for the parent.
Up 1 over 1.
Up 1 over 1, up 1 over 1, right? Like this. Or down 1, left 1, and he looks like this. Something of that nature. Right there. Okay? All right, now, what is the 4 doing to it? What is the transformation
It's a
here?
slope.
It is stretching it how?
Times 4.
Times 4 how? Vertical or horizontal?
Vertical.
It's a vertical stretch, or VS, by
4.
4. It's a vertical stretch by 4, so it's making it 4 tall. So the slope, still starting at 0, slope is up 4 over 1, up 4 over 1, or down 4 left 1, down 4 left 1, etc., right? And we draw our line, and that's what it looks like. Now, also, some of you might argue, well, that 4 might as very well be in parentheses. It could be in parentheses, right? But if it's a if you say that it's horizontal, it has to be a horizontal compression by 1/4. Does that make sense? So you could argue that that's also a horizontal compression by 1/4 because it's 1/4 is as wide as it was before. Does that make sense? Okay. It's 4 times as tall, but it's a 1/4 as wide, right? Okay. So there's how that works. All right. Next. What? What do you,
Do you have any more notes? Because I feel a lot on.
for 1/8?
Yeah.
Oh heavens, child.
You
I have what?
Chase,
Oh, Chase.
you know, sure, it's smart you keep all your papers in your.
I kind of didn't get it graphed all the way.
I think you left it in here.
The thing. Whatever you're doing.
That's why you keep them all in here, baby. Oh, you got like a bunch of
Okay.
papers.
Next.
Just keep it dressed.
This one they don't have us graph him.
No one
You
cares.
count
They
one.
But-
I'm like, okay.
What does HC stand for?
Horizontal compression.
Filter.
And vertical stretch by.
Okay, so part B, they don't have us graph this thing. What's the parent? Y equals x. This is a linear function. Now, be careful when there's negatives involved because technically there are 2 things that are happening to this function.
Reflection.
It's a reflection and another thing, right? So there are 2 things, and that is totally legal. You can still have 2 things, right? So the parent function is y equals x, and then we have 2 things happening. I'm going to do 1, 2. Do you want to deal with the 2 first or the negative first?
Negative.
Negative? Okay, so we have a negative and we have a 2. All right, negative is a reflection how?
Across the y-axis.
Reflect over x, right? Okay? Reflect over x. Now, the 2 is a vertical stretch by 2. Now, somebody might argue instead that that is a horizontal compression by
Half.
1/2, right?
What are the little bubbly things with the numbers in them?
1 and 2. I'm just saying that there's 2 things happening. So I'm listing them out. Number 1, number 2. Yeah.
So
Okay.
reflect over x.
Reflect over x is the first thing. Second thing is a vertical stretch by 2. Okay, now, if you're confused, don't listen to me. Okay? If you're not confused, hear me out. Okay? I'm going to go over here. Let's say this. Okay? For a linear function, a vertical stretch by 2 is the same thing as a horizontal compression by 1/2. Okay? But let's look at this. Let's say that our function is y equals 4x squared. Okay? The parent would be y equals x squared, correct? Okay? Now, the 4 is a vertical stretch by 4, yeah?
And then a horizontal.
But
compression.
is it a horizontal compression by 1/4?
No.
No. What's it a horizontal compression by?
4.
4?
I don't know. 16?
4.
No, 1 over 16.
2.
No?
You're close.
1, 8. 3, 4.
It's technically a horizontal compression by 1/2 because when it's a horizontal compression by 1/2, you plug it in and you make it 2 when you plug it in, but it looks like this when you plug it in. Isn't 2x squared in parentheses the same thing as 4x squared?
Yeah.
So for a nonlinear function or for a quadratic function, vertical stretch by 4 is not the same thing as a horizontal compression by 1/4. It's 1/2 instead because you end up squaring it, right? Okay, if that was confusing, don't listen. If that was okay, then there you go.
Wait,
All right?
Why'd you make it a half?
Because when you plug it into the formula, you make it a 2, but it ends up having to be squared because that's the apparent function, right? And 2x squared will be the same thing as 4x squared. So those two are equivalent to each other, even though they're not the same number, right? So if it's not a linear function, it won't be always the same number, the reciprocal, okay? If that was confusing, don't listen.
It's a vertical stretch by 4 and a horizontal compression by 1/2.
Yes. Okay, let's go down to this guy. Identify the transformations. The graph of a quadratic function is shown on the grid. If the graph of f of x is translated 5 units right and 3 units down, they want us to take this already existing graph and make it 5 units to the left and, 5 units to the right and 3 units down. Okay, where is he at right now? What is this coordinate point at right now?
It's about
Negative?
1,
negative
2.
1, 2.
Negative 1, 2. Okay, I'm going to go 5 units to the right. So where will he be at if I'm 5 units to the right?
4.
4, right here. That's 5 units to the right. Okay, and 3 units down, he will be at?
Negative 1.
Right here. So this is really what he looks like. I want to find the equation of that function. Okay? So that's the function that I want to find the equation of. Now, what is his parent? What does he look like?
Negative x squared.
Y equals x squared. Okay, now we got to figure out what's doing to him, all right? Y equals x squared just looks like this, right? So let's figure out how we got from the purple to the blue. What did we do to it? I heard Reese say that we reflected it. Reflect over x, right? We've made him go down. Okay, number 2, we've shifted him what way?
Right to 4.
We've shifted him to the right 4, right? Okay, and we've shifted him, the third thing we've done is down 1, okay? We're going to incorporate all of those things into this function and see which answer it is, A, B, C, or D, okay? So let's figure this out. If I take that thing and I reflect it over the x-axis, it will become negative x squared, right? Negative x squared. And I'm moving him over to the side because that's what I want to do. Negative x squared. That's reflect over the x-axis. That negative does, okay? If I go to the right 4 units, what does that do?
Inside.
Inside, and it will be minus 4. So it'll look like that, yeah? Minus 4 to the right 4 units, okay? What does down 1 do?
Minus 1 on the outside.
Minus 1 on the outside. That's what that function looks like. That's a combination of all 3 of those things into one, right? Which one is that?
B.
B is actually the graph of that new parabola, that blue one. Does that make sense? So you can do more than one combination at a time. You can do 3 things.
Why,
Up. What? Yes.
Why did we go to the right 4? Did it say to go to the right 4?
No. So they gave us this function here, this one, right?
Yeah.
And they said that they wanted us to move that one 5 units to the right and 3 units down. So we've created the blue one. Okay.
Yeah.
Now the original parent function is this purple one, right?
Yeah.
So now we're comparing the purple one to the blue one, and in comparison to the purple one, the blue one is 4 units to the right. Right? The original one is the purple one. We've moved that one 4 units to the right and 1 unit down,
Okay.
and we flipped him. So
we're
now
doing this to
his
the
actual.
parent function.
Yes,
Okay.
you're doing this to the parent function. You always have to compare it to the parent function. Okay? Good? Happy with that? Okay. I'm going to, since I'm still recording, I'm going to go to your homework assignment, and I explain this real quick so the people who are watching this video, they can get this.
Oh, it's a paper.
On, let's see, here we go. This is what I want. On skills practice, we'll end up doing all.
What's that say?
I hope you can.
Skills practice, we'll do all. On practice, we will just do the odds.
Are you sure that it was?
Okay, odds on practice, skills practice is all. I'll repeat that again when you guys get your paper. Everybody say bye, people on the video.